Welcome students, we got a beautiful question. Integral dx over x raised to the power of 1 over 3 positive x raised to the power of 1 over 6. Now what I wish to do is I would like to take p to be equal to x raised to the power of 1 over 6. Now I'm going to differentiate this over here, and that differential will give me dp is equal to 1 over 6 times x raised to the power of 1 over 6 negative 1 times the differential of x, that's going to be dx. So this is going to be 1 over 6 times x raised to the power of 1 negative 6 divided by 6 times dx. This is going to be 1 over 6 times x raised to the power of negative 5 over 6 times dx. This can be rewritten as 1 over 6. I can push this down. This will be x to the power of 5 over 6 with the dx being on the numerator, and this is going to be my dp. Okay, fair enough. Now we need to get x raised to the power of 5 over 6. Okay, that is one important part. Now what I wish to do is I would like to cross multiply. So this is going to be 6 times x raised to the power of 5 over 6 times dp is equal to dx. Now don't be worried, I'm going to change this x within a minute. Now over here we have x raised to the power of 1 over 3, right? So what I wish to do is I'm going to square both sides. So if I square both sides, this is going to be p squared is equal to x raised to the power of 1 over 6 raised to the power of 2, which is going to give me x raised to the power of 1 over 3. This is p squared. Fair enough. Now I need to get the value for x raised to the power of 5 over 6. So now what I'm going to do is take both sides to the power of 5. So this is p is equal to x raised to the power of 1 over 6. So now you raise it to the power of 5. This is to the power of 5. This is raised to the power of 5. Now a raised to the power of n raised to the power of 1 over m is equal to a raised to the power of n over m. This is the formula. So by this formula I get p raised to the power of 5 is equal to x raised to the power of 5 over 6. Now you know I have a representation for x raised to the power of 5 over 6. So come over here. So this is going to be 6 times p raised to the power of 5 times dp is equal to dx. Take this and substitute it here. So this is equal to, in place of dx I substitute this one, 6 times p raised to the power of 5 times dp divided by, in place of x raised to the power of 1 over 3 I substitute p squared. In place of x raised to the power of 1 over 6 I substitute p. Now this is equal to 6 times p raised to the power of 5 dp divided by, I can take p out. So if I take p out, I will get a p positive 1. A p and a p can be cancelled, giving me 6 times integral p raised to the power of 4 times dp divided by p positive 1. 6 times integral p raised to the power of 4 over p positive 1 times dp. Now I want to integrate. I cannot directly integrate this because the degree of the numerator is greater than the degree of the denominator. So what I wish to do, I will have to divide p raised to the power of 4 by p positive 1. Now place p positive 1 over here. Now what value should you place here so that multiplied with p will give me p raised to the power of 4? That's going to be p cubed. So p cubed times p would give me p raised to the power of 4. Followed by p cubed times 1 will give you p cubed here. Now you change the sign. When you change the sign, these two gets cancelled, you get negative p cubed. Now place a negative p cubed here. Now the question is, what should you place here so that you get a negative p cubed? That's going to be negative p squared. Negative p squared times p would give you negative p cubed. Negative p squared times 1 would give you negative p squared. So you change the sign. So you get positive p squared. Of course these two gets cancelled. Now place positive p squared there and you place a p squared here. Now the question is, what should you place here to get a p squared there over here? So it's going to be positive p. P into p is p squared. P into 1 is going to be positive p. Now change the sign, you get a negative p. Now place a negative p. Now what should you place here to get negative p? Clearly you need to place negative 1. Negative 1 times p will give you negative p. Negative 1 times positive 1 will give you negative 1. Change the sign, negative, change the sign, you get positive 1. So therefore p raised to the power of 4 divided by p positive 1 is rewritten as p cubed negative p squared positive p negative 1. This is the quotient, followed by the remainder, that's going to be positive 1 divided by the divisor. Now the question is, you need to perform the check. Of course I am performing the check for your understanding. What is the check? This multiplied with this added with this should give you this. Let's see. So p cubed negative p squared positive p negative 1 is multiplied with p positive 1 added with 1 and then divided by p positive 1. So p cubed times p power 4, p cubed times 1 will give you p cubed, and then p squared times p will give you negative p cubed, negative p squared, and positive p squared, and positive p, negative 1, positive 1. So clearly this goes off, giving me negative p, and everything goes off. Okay, negative p, that's negative p, negative 1 and a positive 1 divided by p positive 1. Okay, this also should go away. So this is equal to p raised to the power of 4 divided by p positive 1, which is equal to the left hand side. Okay, fair enough, right? So this is correct. So coming back to the integration, so therefore let me perform the integration. 6 times integral p raised to the power of 4 divided by p positive 1 times dp is equal to 6 times, this is rewritten as p cubed negative p squared positive p negative 1 positive 1 over p positive 1 times dp. Now this can be further rewritten as 6 times integral, I'm distributing the dp, p cubed times the dp negative p squared times dp integral p times dp negative dp, and then positive integral dp over p positive 1. Okay, fair enough. This is what we have to integrate. Now this is going to be p raised to the power of 4 divided by 4 negative p cubed divided by 3 p squared divided by 2 negative p, this is going to be positive ln of p positive 1. Okay, now you can simplify this, rewrite it, or make the substitution. Now what is the value of p? P is equal to x raised to the power of 1 over 6. Substitute that. So this is equal to 6 times x raised to the power of 1 over 6 raised to the power of 4. So I can simply place 4 there, divided by 4 negative x raised to the power of 1 over 6 times 3 positive x raised to the power of 1 over 6 times 2 divided by 2 negative x raised to the power of 1 over 6 positive ln of x raised to the power of 1 over 6 plus 1. You got to place the modulus sign. Now this can be rewritten as 6 times, you can reduce this, right? 2 and 3, x raised to the power of 2 over 3 divided by 4 negative x raised to the power of 1 over 2 divided by 3 x raised to the power of 1 over 3 divided by 2 negative x raised to the power of 1 over 6 positive ln of x raised to the power of 1 over 6 positive 1. This is what you've got. Now this can be further rewritten by distributing 6. So 6 over 4. Now I wish to rewrite this as third root of x squared negative root of x divided by 3 positive third root of x divided by 2 and then sixth root of x followed by ln modulus sixth root of x right? Positive 1, positive arbitrary constancy. Now this is the solution for this question. Now you can simplify this further. Now there is one important thing. 6 is taken inside, 6 is taken inside, 6 is taken inside, 6 is taken inside. So 6 has to be placed, right? So you can further simplify this, or what you can do is, I think that's the best thing. This is the best solution. If you have found something else better than this, please put it in the comment box. Thank you, students. Until we meet again.